guys get a ton of tags out there, don't you?
Everybody can shoot buck to get a doe tag. That's on a lottery almost.
So it's a little different than I'm thinking, because some of those areas out on the East Coast seems like you guys can shoot a pile of deer. Some of these states, because we only get basically one deer out here. There's certain small exceptions, but
yeah, there's so many deer there. I mean, it's a problem. I mean, people don't hunt like they used to. So car deer accidents are just all over the place. So some guys in the shop, they'll get 3 or 4 deer a year. If they have land or hunt in different regions, they can get more tags.
Right there in upstate New York.
Yep.
So where did you grow up in New York, or where are you from originally?
I did.
The name Shabala, what's that? Am I saying it right?
Yeah, Shabala. We don't know. It's
oh, really?
Great-grandpa Shabala came over from Austria. In the 1910 census, it said Austria-Hungary. And then in the 1920 census, it said Austria.
Oh.
So I think World War I was in the middle of all that. So I think it's from the eastern half of Austria.
Okay.
I can't find any records of Shabala coming over on the boat.
Yeah.
So it was probably something else at that time.
Interesting.
Yeah. But yeah, I grew up about 2 hours south of the plant, right on the Pennsylvania-New York border.
And what, do you have siblings growing up, or?
Yeah, 2 sisters, both still in the area. One lives near me, near Niagara Falls, and the other one's back home where my folks live.
Yeah. Did you do sports, or what kind of things did you do as a kid?
I was always slow, small, so not super athletic. I was a good runner.
Yeah.
But skiing, I'd like to ski and golf.
Yeah.
And to this day, I still really enjoy doing both of those.
Yeah.
And I do some endurance sports, triathlons and duathlons, but
that's cool.
That's kind of it. Yeah.
You guys get a shit ton of snow up there.
We do.
Everybody, talks about Montana and like, oh, you guys get tons of snow, and I think it's just this like thing that people think we get tons of snow. I mean, obviously there's areas and there's certain years, but I always say you guys in that lake effect snow out there, where it's like, oh, we got 9 feet last night, or 4 feet last night. I mean, if we get a foot of snow here, it's kind of a big deal as far as in one shot,
Yeah, the lake effect is funny. It's, you have the wind coming off the lake, and it's like a finger. And if the finger's oscillating, then, that's when everybody gets 1 to 3 feet. But when it stops, that's when you see 6 to 7 feet.
That's crazy.
Yeah, it just, for 24, 48 hours. It just,
What's the worst storm that you ever remember?
It's called the October storm. So it was October 13th. October 13th, we got 3 feet of snow.
What year?
Oh, God, it was, I think, 2006.
Oh, so not that long ago.
No, nope. But all the leaves are still on the tree.
Right. It just tears the shit out of stuff.
I mean, it sounded like shotguns going off all over the whole area. We lost electric for about a week. But 2 days later, it was 60 degrees and sunny. Snow was all gone, but there were just trees down, branches, electric lines. So that's the worst that we've ever had.
Those are when I was a lineman, those were the snowstorms that were a little bit more fun to work, because if you were busy working for the next week, you were working generally in pretty nice weather. Yep. It's the snowstorms in January that suck, because if it does tear stuff up, you're just going to be working in cold. Yeah, it's not going to get better.
I mean, you're climbing up were you working on high tension lines?
Yeah, climbing power poles,
Jeez.
Yeah, doing that stuff. So, we have a lot of lines that run through the mountains and through timbered country. I mean, you guys have a lot of timber.
Mm-hmm. How do they get you there? Do you helicopter in, or it's just UTVs? Or
if it's in the winter, usually a snowcat. So we'd have a snowcat that would hold about 5 people, 2 in the front and 3 in the back.
Mm-hmm.
So that was a crew. A crew of people generally was 4. And at times they would fly the lines just to try to figure out where a tree was in a line, and then once they found it, if it's in an area, say up, towards the Idaho line or some of these mountains around here, they would find a crossarm broken on a power structure, and so then we would take a snowcat, load up all of our gear, all of our tools. Well, these tools right here on the wall behind me, for climbing the poles, and then.
How do you get the wires back up? I mean, it's.
Yeah, hoists. There's these capstan winches for, it's basically a big, long, we called it blue rope. It's like really strong, lightweight, like a nylon rope, You actually see a lot of winches these days on people's pickups made with that rope on it instead of the cable. Cable gets all frayed and tears your hands up and turns into a mess, but that rope is really light. So we'd pack literally like a garbage can of that rope, and then strap with like endless slings, strap those shackles to the top of a power pole structure, and then maybe back down to the bottom, run your rope through the bottom one and then up the pole and then down and back out to the wire. And these grips, that you put on the wire, you'd put a grip on it, and those capstan winches, you can connect them to the base of the power pole, and they'll just sit there and kind of spin real kind of slow but high torque, and you'll basically just pull that line up. And then once, you got guys up on the power pole, and they'll lean out, and once you get that wire up close, you can get like a chain hoist strapped into the or clicked into the grips. And, you got to have a chain hoist on the piece of wire going north and the piece of wire going south, and then try to suck it together and sleeve it. But the challenge a lot of times is when that stuff happens, it'll run back through some of the other structures, like the ties a little bit. But then when you're trying to pull it back together, trying to get it slipped through those ties. So sometimes you have to go untie the, few structures either way to try to get some of that wire back.
Oh, okay.
But it's a lot of work. It's a pain in the ass because it's all by hand. And like with the cross arms being broken, you're putting those cross arms up there by hand. So all of it's done with either ropes or winches or hoists,
In the cable, is it spliced together, or you say it's just crimped?
Yeah, no, you'll splice it together. There's different ways of crimping it. I mean, there's compression ones that you actually squeeze with like a squeeze tool. And then it depends on the type of wire, but they have sleeves that are we call them automatics. But essentially they have like the Chinese finger where you stick your fingers in it, but then when you go to pull out, you can't get your finger out.
Right.
And they've got little barbed teeth in there. So you stick that wire in, and then when it goes to pull out, those little teeth and everything clamp onto that wire and hold it together. So if you look at a power line just driving down it, even when you're stretching new line, you get to the end of your wire, you'll put a sleeve in it.
Okay.
So, yeah, it's but back to the, kind of what you were talking about, we really enjoyed like those spring April storms where it was going to get nice, other than the mud. If it snows 3 feet in April or May, or like you say, October, and then it turns 70, you're about to get a lot of vehicles stuck. Bucket trucks and line trucks. And
I bet, yeah.
Trying to drive. That's the other thing is like just trying to drive out in fields. A lot of times you have to do stuff by hand because you can't drive to it with. That's the advantage with winter. Everything's froze.
Oh,
so
okay.
you can drive on that frozen ground. Drive across people's yards and stuff, and it's fine, but not in the spring. You're doing everything in their backyard by hand.
Right.
But yeah, what you were saying though about when the leaves are on the tree, I mean, it's interesting how Mother Nature grew with their own defense mechanisms, right? That sap goes down out of those trees. They lose their leaves, and they can handle tons and tons of snow at that point.
Oh yeah,
but
it's a non-issue.
Yeah, you get that snow in April or May when there's leaves on the tree, or October, it's a problem.
Yeah.
But when you graduated high school, did you go to college, or did you just go to work? Or
so I didn't know what I was going to do at that point. I was not a real good student, didn't apply myself, so I joined the Air Force.
Okay.
So I enlisted for 4 years, ended up extending for a year. And the whole time I was in, I took classes.
Amazing how many bad students end up flying jets.
Oh, no. I was just guarding them. I worked security. I was going to make a career of it, but in the end, I decided to get out. I wanted to go in the FBI.
Oh, really?
So I started taking accounting classes. And I was working at a bar, and all these engineers would come into the bar. And I told them what my game plan was, and one engineer, he's about 6 or 7 cores into the night, and he's like, well, the fucking FBI, they need engineers too. And I didn't like accounting that much, so I flipped over to engineering. And
so at that point, you started applying yourself in school a little better?
yeah, I mean, when I was in the Air Force, I was 4.0s.
Yeah.
When I was in accounting, I had a 4.0 going on, and then engineering, that came to a screeching halt. I mean, that was a solid B student at that point.
Yeah.
Really, really hard.
That works though. That gets you through the classes.
Yeah.
It is funny how I say that all the time with kids in high school, that a lot of these kids that have bad grades, it's just because they don't understand how it's going to apply to their life, or they don't have an interest or a reason. So they just sit there and think it's dumb, and they have other ideas. But it's not that they're actually dumb kids. They just aren't applying themselves right at the moment.
Yeah, and I had one math teacher. She kind of, you had to do your homework. You had to give it to your classmate to grade. So you did your homework every day. And I was an A student in that class. Mm-hmm. So I kind of knew that if I applied myself, I could do it. So it gave me the confidence to go into engineering and give that a shot.
So what engineering degree did you end up with?
Mechanical.
Oh, okay.
Yep.
All right. And how old were you when you graduated engineering school?
22.
Oh, okay. So you weren't in the Air Force very long then?
5 years.
Okay.
I went in when I was 17.
Okay. You were pretty young going in.
Mm-hmm. Yeah. Yep, 17. I was in for 5 years, and then, then a year of accounting, and then engineering. So probably 27 when I was done with engineering.
Yeah. So what'd you end up with? What were some of your first jobs out of engineering school?
Niagara Specialty Metals.
Oh, really?
Yep.
Right out of there, huh?
Yeah,
How did that happen?
So my junior year, one of the professors said there's a local company that needed some part-time help, and I needed the money, so I went out and interviewed. Barry Hemphill was the owner, the president of the company, and his partner was Lou Valerie. They interviewed me. They needed bodies, so they hired me pretty much on the spot. Mm-hmm. So for the next year and a half, I worked. I worked on the shop floor. I was cutting scrap, cutting sheets. Worked on the mill crew every now and then. Just doing whatever they needed me to do.
Just grunt work, pretty much.
Mm-hmm.
Yeah.
Then I think January of my senior year, Lou retired, and a couple months later, Barry asked me if I had any plans after school, and I told him I needed a job. So he made me an offer, and so I knew, in February that when I graduated in May, I had a job. So
that's cool.
Yeah.
What year was that?
94 when I graduated.
Okay.
Yeah.
So what is the history of Niagara? Like when, and for people, they've probably read the description on this, but Niagara is where our steel is rolled for our knives. Mm-hmm. What is, and you're the president of Niagara, right?
Right.
So what is the history of Niagara? When did it actually start?
So Barry and Lou started it in 1982, primarily to roll tool steel into sheet and plate. So it is all industrial applications. And, their specialty was they could do it quick. They could get small orders and turn them around. They could do custom sizes. And
so that was kind of their goal, was to not necessarily be worrying about the huge steel industry and the big stuff, but more of like just that small specialty stuff.
Yeah, we sell by the pound. I mean,
Right.
U.S. Steel or Carpenter, they're tons.
Yep.
And we're selling by the pound.
Okay.
And so they bought a lot of their own steel, but then they also got into conversion work where people would send them steel. So, besides tool steel, they started doing stainless. They do some aerospace alloys. And Crucible was the biggest customer for us.
Okay.
They would send us truckloads of CPM to roll, and we would ship it to their warehouses all over the country.
Okay. So how was that? Did they, when they started Niagara, was that because, and I don't know a lot of the history of the steel industry in America, but obviously we've lost a lot of the steel mills and the steel industry, but was that specialty stuff, was that something that others maybe smaller specialty companies were going out of business, or how did they spot that as kind of a niche area that they could survive in?
So they both worked at another mill locally. It was called Simon Steel, and it was a big union shop. So 12 guys on a crew where we have 5 guys. So, Barry started off at U.S. Steel. He went to Simons, and he said right away he could tell that it was in trouble.
Really?
So I gave him the idea to do it himself. He took out a loan. During nights, he would go down and with some of the guys from Simons and start building the Niagara. He started making he said 37 truckloads of steel, or not steel, of equipment.
Yeah.
He bought from a shuttered mill.
Oh, wow.
So they would assemble at night and then go back and work at Simons in the daytime. And his bosses found out and they fired him.
Oh, really?
Fired him and Lou right there on the spot.
Oh, wow.
So then he had about 6 months to get it up and running. And at night, some of the Simons guys would come and work there under the, all under the table. But and then a few months later, after Barry and Lou got going, I think Simon shut down. So a lot of work just got shifted their way.
Okay.
And he said, there's definitely some touch and go periods. I mean, I think he said he took out a $2 million loan to start the business.
Back in the 80s?
80s. And
that's a big loan back then.
Yeah. And the banker said basically, everything you own now, we own.
Right.
And
that sounds familiar today.
Yeah.
Sounds like what we're being told.
Yeah. Yeah. So then 6 months later, he ran out of money and he had to go back and get some more. But then things kind of took off. Just things happened, and they just continued to grow up until this day.
Yeah. So when you got out of college, were you still kind of working the shop for quite a while, or did you start putting your engineering degree to use?
I never really did much engineering. Database, so everything at that time was. And when I graduated, I was in the office. I basically, Lou had retired, and there's only Barry, Ray, and Marilee in the office. So he had a sales manager and office manager. So I kind of helped out with order entry and process improvements. So that was my engineering, was just creating a database, and then any opportunities I could find to make improvements in the shop, I would do that. But most of the ideas came from the guys in the shop. I mean, we have just an outstanding crew of people that if something's hard, they want to try to find an easier way to do it, and that's where the bulk of our ideas come from.
Right. So explain to people a little bit the process, right? Because you're not making the steel, right? But maybe explain a little bit of the process about how, say, like this crucible steel, this powdered steel, kind of from start to finish, or as best as you can.
Sure.
Maybe even like with MagnaCut, you guys roll our MagnaCut, and that steel came along kind of as a brainchild of Laren Thomas. How'd that process work with Laren on developing MagnaCut?
So,
because you guys were more involved with that kind of from the beginning, probably than like normally you're getting just a steel that's already been being made probably for years or whatever, and you're a mill that rolls it. But you were more involved with MagnaCut really from day one, weren't you?
We were. Yeah, Laren, he had the idea for MagnaCut, but he couldn't find anybody to make it for him. He's just an individual, and he can't, he couldn't spend $50,000 to get a heat made. And, if he didn't have a business, they're not going to make it for him anyway. So we talked to Crucible about it, and told him, if it doesn't work, we're on the hook for it. We'll just scrap it. And fortunately, the first heat worked like a champ. So,
what gave you the confidence to make that gamble?
We ran it by the metallurgists at Crucible, and they talked to Laren, and they said it looks like it has potential. They didn't think it was going to do exactly what he thought it was going to do. Fortunately, it did. I mean, being only 10% chrome, historically you need, I think, 14 or 16% chrome to be stainless. And so they thought, with only 10% chrome, how is this going to be a stainless? But there's no chrome carbides. It's all tied up in the in the base of the material. So all the chrome in there is for stain resistance. So we thought it had a lot of potential. He showed us what the property should be. It seemed like a kind of a paradigm shift in the knife industry. So to take a chance on that didn't seem like too big of a risk for us.
Sure. So how did that process kind of continue? So Laren comes to you, you got the idea, you kind of talk to Crucible. All right, we're going to kind of try and do this. What happens next?
Yeah. So we sent him a purchase order. and they melted, I think it's about 3,500 pounds. A typical heat, a CPM is 5,000 pounds. So they were able to make a small batch. So we got 3,500 pounds. We rolled a few sheets. So we received our steel from Crucible either comes in about 5 inches thick and 11 inches wide, or 4 inches thick by 14 inches wide. So these rectangular slabs. And, we get them in. We cut the blocks into, they're 1,700 pounds a piece. We cut them into 200 to 1,200 pound blocks. For sheet, we'll hot roll it down to 1/2 inch, cut it up into some smaller pieces, anneal it. Then a couple weeks later, it goes to our sheet mill operation where we roll it down to the final size. People always ask how many passes does it take? So going from 5 inches down to 1/2 inch is probably anywhere from 10 to 15 passes. If it's a real brittle grade, then you might just do 2 or 3 passes. It goes back in a furnace, heats back up. So pretty laborious.
Yeah, because not all steels you can treat the same way, and
right.
Not all of them put up to the same kind of force and stress.
Yeah, some alloys you can roll all the way down, never reheat it. Some really, really bad ones like Rex 121, it's 1 or 2 passes and back in the furnace. So it just takes a ton of time. And
that process we saw, and maybe I'll try to get Henry to drop some video over the top of this from when I was in your shop, but that where they're running the forklifts and they're coming out of that big oven, that's kind of that first stage, right?
Correct. Yep.
Yeah, and then what shop do you call that?
That's our rolling mill.
Just your rolling mill, okay. And then it goes to the sheet metal shop.
Right, sheet mill. Yep.
Okay. So you roll that steel out, and then what do you have to do with it?
After rolling, it gets annealed. So, because after you hot roll it, if you let it cool to room temperature and were to handle it, it probably would just break. It's really, really fragile at that point.
Yeah, explain that, like what the annealing process does.
So we heat it up to 1,600 to 1,650 Fahrenheit, and then it slow cools. It has to cool no more than 25 degrees per hour. So depending on how much steel we have in there, it's 3 to 6 days.
Oh, wow.
Process. So, yeah, it's maybe 12 to 24 hours to heat up, and then just a slow cool down for the next 3 to 6 days.
And that's relieving stress?
It relieves the stress. I don't know all the metallurgy behind it, but it makes it's as soft as it's ever going to be. So, at that point, you can take it out, and you can be pretty rough with it.
You could bend it or drill it or do whatever you want to do with it, and it's going to be pretty easy to work with at that point.
Yeah, most grades. I mean, some of the stainless grades or high-speed tool steels are you can't bend them too much, or they're still going to crack. But
for people to understand this, if you don't do that process and you end up going through, even if you got through the rolling, if you don't do these annealing stages, you build up a bunch of tension and stress in that steel. And if we cut blades out of it later and you go to heat treat them, you could have all sorts of problems, whether warping, cracking.
Oh yeah.
You're gonna create downstream problems for people in the future, correct?
Yeah, it's not even an option. I mean, if we shipped you a load of steel that was unannealed, you would get it in just pieces. It would just shatter all the way across the country.
Yeah, sure. It's that hard and that stressed out then.
Yep.
Yeah. Have you ever Rockwell tested it or done anything like that when it's in that state? Like,
we haven't, but we could. I mean, we have. You saw when we roll it. Well, you didn't see that. When we roll the sheet, we gauge it right there at the mill, and we shear the edges and ends off.
Oh, so you could test one of those.
Yeah, so we have some.
Be interesting.
Scrap in the bins. We could check that out when. In fact, I'll send a note to Tim and Andy, have them check it out for us.
Just out of curiosity. Not that it would even at that hard, it's still not the right. It's not like it's been heat treated, but it'd be interesting.
Yeah, I'm sure it's in the mid 60s.
Yeah. So it goes into the sheet mill and gets rolled from there after anneal?
Yep, after the first anneal, we would roll it down to the final size, gets a second anneal. Out of there, we would flatten it or, sandblast. So we take it right to our sandblast area, we clean it up, flatten it, and then
and that sandblast is to get all the scale off and
correct.
Clean it up.
Yeah, it's a nice gray matte finish when we do that. So it's any of the loose scale. It won't remove any thickness. It doesn't take care of any decarb that's on the surface, but it just gets all the loose junk off of it.
Yeah, I noticed when those guys were even doing that initial rolling process when it was just going down to that 1/2 inch mark, as they brought those loaves, what do you call them coming out of the?
We call them blocks.
Blocks.
Yeah, they're just slabs of steel.
Yeah, they put them in this kind of steel box essentially, and basically looked like they were pressure washing them off, just using water to kind of blast that scale, right?
Yep.
That way, when you're, and even as they were coming through the roll, they were blowing them off. I'm assuming to just keep from pressing that loose scale down into the steel, have a really nice clean finish.
Mm-hmm. Yep.
Yeah. So once you've come out of that final roll and you've done your straightening, how's that straightening done?
So we have roller levelers, real high precision roller levelers. That's also, besides annealing, when you run through the roller leveler, it relieves a lot of stress. Okay. So when I first started, we had levelers that weren't precision roller levelers. So there was still a lot of stress in there, and you could tell because you would shear strips, and they just curve on you. So then you had to flatten individual strips, and it was just a real hassle. Mm-hmm. We went to an IMTS show one year, and we saw a leveler in action where a guy was putting in it was actually a flag, cut out flag that was all curled up, and it came out just panel flat. And then we started reading into it, and we bought one. I mean, Barry just said, "Okay, we need one." He wrote a $500,000 check, and we got our first roller leveler, and I think now we have 6 of them in the plant. And when we shear strips, now it's just very minor straightening, but it pretty much does relieve all the stress in there.
Yeah. So at that point, are you ready to kind of trim that sheet up, or what happens after the leveling?
Before it goes to leveling, it's already sheared.
Okay, so you've cleaned up the edges and stuff.
Yep, if it's a full sheet, it's sheared. If it's, then we level it, and then if we're cutting strips or laser cutting, you go there, to get laser cut or sheared into strips or saw cut, and then it would get inspected and reflattened if needed.
Okay.
Box it up and ship it.
Yeah. It's interesting. I was telling our employees about the trip out there about, and it's hard. I would love to get this across. Like we talk about American made and whatnot, but I don't think people understand. There's other parts of the process too of making a knife, right? The Hanna material's made somewhere, right? Mm-hmm. And there's people just like you guys making Hanna material. When it's hard to explain, and even for myself, like seeing it in person, how many people and how many steps are involved in the process of ending up with one finished knife. Mm-hmm. It's pretty amazing, really.
Yeah, and the amount of yield loss. I mean,
yeah. So talk about that when you get a 1,000-pound block in from Crucible that's ready to roll down into a sheet of steel. If you start with 1,000 pounds, when you send that out to Montana Knife Company as a finished product, how many of that 1,000 pounds is left?
So for your product, because we roll full sheets and then grind it.
Yep.
So probably 680 to 700 pounds goes to you.
So 70% of that material is remaining, 30% loss, basically.
Yep.
Yeah. That's pretty incredible. So yeah, you're buying, if we're buying 1,000 pounds from Crucible, we're needing to order 1,300 or 1,400 pounds to actually. I mean, you're ordering 1,300 or 1,400 pounds to deliver to us 1,000 pounds,
right? And then you cut the blanks out of it. That's probably another 50% that gets thrown out.
Yeah, it's not quite 50, but it's probably another 30. Mm-hmm. Yeah, which is a good point. I mean, when our steel is laser cut, we do what's called a nesting program, and we nest those blades in as close as possible. And, the computer wizards will play around with how do we use that material as efficiently as possible. But no matter what you do, you end up with, I actually have a stack sitting over in my other shop. I want to make a railing for our new building out of those sheets.
Oh, yeah. Yep.
I think it's going to be cool. We were talking about this new building and the price of this stupid-ass railing that they want to put along this catwalk that we're going to kind of build where you're going to go into the office area. And I was like, God, why are we paying for all that when most railing, right, has, to be of a certain code, I think the holes have to be less than 4 inches, right? In diameter, so a baby or somebody can't crawl through it, or a small dog or whatever. And I'm like, well, our blade stock will make for perfect railing. Take those sheets of steel that are, 24 by 6 foot or 4 by 6 or whatever size that we have. And I figured we can weld up some frames that basically slide those in.
Oh, okay. Yeah.
And just use those. And then every piece of that railing could be a different blade, which I think will really be cool.
Oh, yeah.
The whole length of that building, I mean, that building's 275 feet wide that we're building. That railing's going to be probably 250 feet long, 225 feet long. So we'll have a different section of blades in every piece of that railing. And then we actually need the same thing actually going the other direction. So, I mean, we're going to have probably 400 or 500 feet of railing that we can actually use.
Oh, wow.
Those blanks out of, which will be cool.
Good.
But yeah, and the advantage that we have compared to yours is true loss. I mean, there's probably not much out of yours that you're getting to recycle. Where ours, when we cut those blades out, at least we're still getting to recycle some of that steel, get a little bit back.
Yeah, I mean the edges and ends. I mean that's
you can recycle some of that.
Oh yeah, that goes right back to the mill.
Yeah,
we sell it back to Crucible or
okay.
If it's low value stuff, then a local scrap dealer.
So now, do they just melt that right back down?
They do. Yep.
Wow, interesting.
Yeah, all the Magna Cut. We're going through so much Magna Cut, and they have to melt a lot more. So, probably every 3 weeks, we're sending them a truckload of scrap.
Oh wow!
And they pre-melt some. In their AOD shop, I think they pre-melt something that's close to Magna Cut, and they mix it with our scrap, and then they add in the elements to get the final chemistry,
kind of balance it out. Mm-hmm. Interesting. That's pretty cool. How has it been with being in the steel business, with competing with China and with overseas, and we hear so much about that, and how is it? How have you guys been able to survive when so many other mills have gone down?
So, I mean, when I first started, our biggest grades were the commodity tool steel grades, so S7, M3 Type 1, A2. And we were selling 500,000 pounds a year of that stuff. Mm-hmm. It's all obsolete now. We sell hundreds of pounds.
Really?
So we have one heat of...
what replaced that?
Well, mills in China and
overseas.
India.
Really?
Yeah, they can sell it here in sheet for, say, $1.20 a pound, and we buy the slab at $1.50 to $2 a pound.
Before you even put your time into it.
Right. Yeah, so we're selling it for $8 to $12 a pound, or whatever the price would be, and
yeah,
the only reason anybody would buy from us is if they're just desperate. They're in an emergency situation. They need some steel fast. So we get those kind of orders, and that's kind of how we survived. Is we moved up the food chain as far as alloys go. We're always doing harder, more difficult to process material, and then the custom sizes, delivering when we say we're going to deliver, small quantities, just really trying to stay agile and keep ahead of it.
Is that kind of your edge to basically stay in business? Is just that basically it's what you're talking about is customer service, frankly.
Mm-hmm. Yep, we have a really good reputation, I think, not only in the cutlery business but in industrial applications. That if we tell you 4 to 6 weeks or 5 weeks, we're going to deliver then. That
is the challenge with ordering from overseas. And I guess if you have the kind of business where you just know 2 years from now we're using this many pounds, then maybe for those people it makes sense that they can pre-order 100,000 pounds of steel to be delivered 2 years from now. But for us, if we were getting our supply of steel from overseas and you asked me, okay, we need to put the order in for 2026 like today,
right,
in order to get it, I'd have no idea. Like there's just no way with the way we're kind of growing, and we're trying different things. We're moving into tactical, or we might be making a folder or whatever we're doing, but there's no way to calculate or to project your usage. So a company like yours, obviously, besides the American made part, being able to have lead times that are, 6, 8, 10 weeks, whatever that is, at least it's a known quantity, and you're not looking out 2 years.
Right.
It's a lot easier to plan for sure. Mm-hmm. And to be able to buy it in smaller quantities where you're not like, hey, your minimum order is 100,000 pounds,
right.
you know.
And you get the size you want. I mean, that's what I've heard from the other mills is that it's it's 5,000 pounds of size A, B, or C.
Yeah.
And you'll get it when we get it to you.
Right. How has it been as far as retaining and having employees? Because it's a lot of hard work. I mean, those guys are in there. It's hot. They're running these big, huge forges, kilns, grinding, dirty, dusty. How's it been for you to have good, consistent help?
So when Barry started the company, he initiated a profit sharing program. So every month the guys get 25% of the profits or net income, 25% of net income every month. And it's
so you're really employee owned now.
Well, then that's the other part of it. So profit sharing has been from day one. He's always paid employees every month. In a given year, it could be 40, 50% of their hourly wage.
Okay.
So it's a motivating factor for these guys. They want to do high throughput, minimal waste,
right?
Rejections. They don't want any rejections getting out because that comes right off of the
costing
top line.
them money.
Mm-hmm. And when we get busy, they find ways to get it done. When we tell them we might have to hire somebody, they always hold on. Let's see if we can still do this with what we have.
They don't want to divvy up that pie any more than they have to.
Yeah, so they work really hard, and then when we have an opening, they don't want to recommend a dud, so they tend to recommend really good, hardworking guys, and so I mean our turnover is minimal because it takes 3 to 5 years to train these guys to learn all the different jobs in the mill, and to have a constant revolving door, it would just be unsustainable. So. I mean, we have 2 guys, they're going to retire this year. They've been there 40 years.
Wow.
I'm number 4 on the seniority list right now. I've been there 30 years.
Really?
Yep.
Wow. That's pretty cool.
Yeah.
And not a huge shop either. I mean,
39 employees right now. We were up to about 43 during COVID. And, right now we're back down to 39.
Yeah. It's good size, but it's not like hundreds and hundreds of employees. That's pretty cool.
No, it's very manageable. I mean, I know everybody in the shop. I walk through, I like talking to them, see what's going on, and
right.
So it's it's a good size.
Sure.
And then you mentioned the employee-owned portion of it. So in 2004, Barry essentially gave us the company. He turned it into a 100% employee. It's a ESOP, so employee stock ownership plan. So at that point, he stayed on as chairman and CEO. Made me president, and he just said, "Don't screw it up. Let's keep this thing going." And so the benefit there is we don't pay, as a corporation, we don't pay state or federal income tax.
Oh, interesting.
But when employees get shares of the company based on formulas from the DOL, so the deal is when they retire, we have to buy their shares back.
Oh, okay.
So that's when the government gets their money. Is if the guys start taking cash, then they're paying their taxes.
Right.
So we've been 100% employee owned for 20 years now.
Wow, that's pretty cool.
Yeah,
that's awesome. Yeah, that's really cool to know. With the steel industry, what do you think? With we're about to potentially have another a new president again. And you hear different things about tariffs on stuff overseas and, the effects on the economy and what that can mean. Is it good? Is it bad? Is it just going to drive up the price of products, finished goods? How helpful or beneficial are tariffs and stuff like that from a governmental level? How beneficial is that for a manufacturer like yourself here in the U.S.?
I don't know. I mean, we don't. There are foreign mills that make powder steel, and I know last time they had 25% tariffs. It definitely hurt them. They couldn't import as much steel, so I think Crucible benefited from that a bit. And by proxy, I guess us. We did benefit slightly to our distributors that didn't want to import from overseas or pay the extra 25%. But it wasn't like it. Our business grew 25%, or
right.
It wasn't that big of a deal.
Sure.
And when the tariffs came off, we do see more foreign steel coming in because our distributors, they buy it, they send it to us, and then we process it and ship it to them. So either way, we're still rolling steel and we get paid for it.
Yeah. What do you hear about, the lack of quality from overseas or the inconsistency? And I would imagine it's kind of by mill, but man, I've heard some horror stories about some of the stuff coming in from overseas versus American mills.
Well, I'll clarify, it's all coming from Europe. Anything we're processing from overseas, it's Europe. Nothing from India or China. They do it themselves.
Oh, really?
We'd be too expensive.
Yeah.
So, from the European mills, it's top notch. Really good material.
Sure. Yeah, I would imagine from, like our 5200, that stuff has come from Austria and Switzerland. You're not going to necessarily find it over here being made. But that steel, is great. And I would imagine European countries, they've always been famous for their steel, Swiss steel and whatever. But, I do wonder about the quality of the steel, even though you guys aren't processing it. I just don't know if there's industry talk about like the difference in grades of steel or the qualities or consistencies of, steel from India, China versus, American or European made steel. Maybe it's supposed to be the same alloy, but if we see,
I think it is
variation in it.
Yeah. I think, some of our tool steel distributors, they buy quite a bit. They're savvy. They really scour the market and buy when they see good opportunities, and they wouldn't buy it if it was substandard.
Right. Yeah. Yeah. It's interesting. It's, have you guys, with equipment, that's one thing when I walk through there, a lot of that equipment looks like it's old equipment, like it's been going for a while. What are some of the age ranges of some of that, the rolls and stuff in there?
Oh God. Well, the rolls will typically,
you'll change the rolls themselves out quite often, I would imagine.
Right. Every 2 weeks on the sheet mill, 8 to 10 shifts, we got to take them out, resurface them and put them back in service.
Now, when you say that, you make that sound like it's not a big deal. These rolls are, 4 feet in diameter or something like that?
The sheet mill is 30 inches, and the rolling mill is 24 inches.
By how wide? 6 foot?
The whole from end to end, about 109 to 119 inches, depending on the barrel width.
Wow. So
there's 14
9 feet to
yeah, I think 12 to 18,000 pounds a piece.
Yeah. So and that's amazing because you said about every 10 heats, you said you got to take them out?
10 shifts.
10 shifts.
Right.
Okay. Couple shifts a day?
No, right now it's just one shift a day.
One shift a day. Okay. So about every 10 days then, you're having to pull 12, 15,000 pound rolls out and then grind them back to shape?
Just to get dents in the surface, or the center might wear out a little bit. So you're removing maybe a 1/16 and 1/8 of an inch.
Yeah. But that's no small task. That's
They make it look easy. Yeah, you put, we got Craig back there on the grinder, or Mitch. They put it on. It's a big lathe with, you didn't get a chance to see the wheel.
I did see it. I saw it, and it had coolant running over the top of it while it was on.
Okay, yeah. Yep. But in the background, there's a 30-inch diameter wheel.
Yeah,
that's,
I didn't see that.
About 2 inches wide.
Yeah.
And, that thing is just back and forth indexing all day long. And it can take, typically they get 1 to 1.5 rolls a shift if they're not too beat up. They're working on one set, and it took a few days to get. They're just kind of beat up, and you're just having a tough time getting them cleaned up.
So back to the question, kind of some of the age of the equipment. How old has a lot of that stuff been in there from the beginning, pretty much?
Mm-hmm. Oh yeah. So the housing where we do the breakdown of this, at the rolling mill. Mm-hmm. That was built in the 50s, I think. Mm-hmm. It is at another mill. They shut down. Barry bought it and brought it up. Mm-hmm. We do have a spare set being made right now, so we should have those by the end of the year. Mm-hmm. But it's just steel. If anything happens to it, we can weld it up and fix it.
Right.
We have bandsaws that have been there for probably 35 years. And the old manual bandsaws, I mean, you replace bearings, you replace guides.
Yeah.
Motors might burn up. It's all
Just
very interchangeable. Yeah.
Yeah.
The newer equipment, we have some CNC, we have laser, water jets, Akuma, milling machine, some automatic bandsaws. The bandsaws used to be just manual where you make one cut. You got to back it up, move the piece, make another cut.
Right.
Now we can do lights out cutting in a couple operations where
those probably won't be around in 50 years though.
They're pretty substantial.
Are they?
Yeah, they're heavy duty. And things will wear out, but
it's the electronics part that's going to be the struggle.
Yeah, we'll have to swap out a motherboard or something, but
right.
We'll pay that price when the time comes.
Yeah. Yeah, but to allow you guys to be able to work, like you say, lights out and just the amount of production. I mean, that's the thing with some of this new technology stuff. I mean, you might find yourself replacing some machines a little bit more often than you would those old school ones, but man, the amount of production and accuracy and whatnot is pretty incredible.
Oh, yeah. I mean, our grinders, Blanchard grinder and a Madison grinder, I mean, those things are, both of them were bought just stripped right down to the bones and then built up with new motors, new controls, redid all the ways, and they'll last another 50 years. I mean, those things are they're bulletproof. You
guys also do laser cutting as well, right?
We do. Yep. We have an Amada laser. We use fiber optic. I think it's a 4 kilowatt fiber optic laser.
So knife makers that are maybe wanting to try to do little bigger projects than maybe they're just custom stuff at their house. If they want to run 100 knives or do something like that, you can laser cut them blades for them. Yeah,
they send us a DXF file. We can, they had to buy the product of a sheet, and we typically have the sheets right in stock. So we just charge them on a per piece basis at that point.
Sure.
We used to water jet everything, and because our old laser didn't have any nitrogen in it, so you'd had a really big heat affected zone. But then once we got the Amada, it's just faster, it's more repeatable, it's cheaper than the water jet, so almost everybody has switched over to that.
Yeah, the accuracy level and those things they're awesome. Yeah. What do you heat all your big forges with that you're heating up these huge chunks of steel with? I mean, you're putting in chunks of steel that weigh hundreds of pounds.
It's all natural gas for the initial mill. Where we do the rolling mill, it's natural gas. And we do have a couple electric furnaces we do some lower temperature material or titanium. Sometimes we have to heat in electric. We can't put it in gas.
When guys go home at night, are they just kind of blocking off doors and shutting them off and letting them try to stay as hot as they can? I mean, I'm just wondering about the reheat time the next day.
Yeah, so they'll turn them off at the end of the shift. So they work, our guys work 4 10-hour shifts. So they finish up at 4 o'clock in the afternoon. They'll turn them off, and then our second shift guys, before they go home, they'll turn them back up to an intermediate temperature.
Okay.
So at that point, it's gone from 2,100 degrees down to maybe 1,100 or so. They fire it back up to 1,600 or 1,900, and then we have an early guy that comes in, and he'll fire them up to the rolling temperature.
That's cool.
Yeah, we just keep that going. I know a lot of furnaces you're supposed to just keep them on. It's not good for the insulation, but it's you can fix it.
Yeah. Yeah, I can't imagine how much natural gas you guys go through in a year.
We're about to go through a lot more. So in our sheet mill, we had 6 electric box furnaces. But, it was kind of a bottleneck. They just couldn't keep up with the amount of rolling we could do. So when you're at the shop, you saw the big continuous gas furnace going in. So New York they're probably not happy about it. They want to discontinue all new gas connections. They want everything to be electric.
Yeah, why don't you run that off of a windmill?
Yeah. Yeah,
solar panels.
Yeah. Yeah, so we're putting in a big continuous gas furnace, and then we're worried that they down the road they won't allow us to make another connection, so we sized it so that we can put in another continuous gas furnace down the road.
Oh, good.
So we're kind of future proofing that.
Yeah. Or you could call it idiot proofing.
Yeah.
If they make some dumb law.
Yeah, and it's going to double our production almost. I mean, we can really just keep feeding pieces in that furnace and keep it going.
That means you're going to charge us less for steel. Is that right? No.
We'll pass along any savings that we can.
I'm just giving you shit. Well, cool. Is there anything else you want to cover on the process people might find interesting or?
No, I mean, the improvements we've made in the shop. I mean, we always kind of limited. We always had about 1,000-pound limit on our blocks.
Mm-hmm.
But we have an excellent maintenance staff. Our crew guys on the mill are really hardworking. So they came up with new tables. So we've done up to 2,500 pounds now.
Wow.
We do a lot of aerospace work. So that's cutlery is about 50% of our business right now. The other 50 is aerospace and defense.
Oh, really?
Tool, die, steel, electronics, medical. So we really try to diversify as much as we can and keep different customers coming in.
Yeah. Do you see new steels coming on the market? Are there constantly people playing with new alloys and that kind of stuff?
We're almost an R&D shop for some of the mills. I mean, I'd say almost every month we get a new grade in that we're processing for either it's mostly aerospace and defense or
like DOD stuff.
I guess they don't tell us what it is. It's a new grade of titanium, and that's it. As long as it doesn't have beryllium in it or uranium, they tell us how to process it. We process it, and it's good to go. But almost every month we get these small test pieces in the roll, and then sometimes it turns into orders down the road. But
are you ever going to come out with a steel that never has to be sharpened ever again?
What's that? Ceramic?
Yeah. The perfect knife blade that
right.
everyone's been seeking forever. Yeah, I find it funny on some of the comments like, well, I use this steel and you never have to sharpen it. And it's like, well, it's probably true if you never use it.
Right. Everything we've ever had. I'm opening envelopes with my knives and they still got to get sharpened eventually.
Yeah, that's what I tell people. Every knife's going to get dull. So it's a matter of how quickly and how easy is it going to be to resharpen.
Yep.
But
what do you see? I mean, is there a demand for you? Is it, do people want tougher blades or more wear resistance or corrosion?
Yeah, I mean, it's interesting. I think it's always generally like people want to be able to resharpen easily, but then they want their cake, but they want to eat it too, right? That whole, quote, which I still don't even understand what the hell that means. But, they want an edge to last forever, right? Mm-hmm. But then they'll complain that it's tough to resharpen. It's like, well, yeah, you're going to give up. Like, it's going to be hard to resharpen if it's going to be some of these super steels that, just have a ridiculous edge holding ability, or they have that, but then they don't have toughness,
right,
in the steel because it's so hard that now that blade's brittle,
mm-hmm.
or you got to make it thicker to put up to more of that abuse. So, I think MagnaCut really hit the mark really well where, it just had such a higher level of toughness. And then the corrosion resistance was, like you say, even better than I think what Laren expected.
Oh yeah. It was out of the park.
Yeah. So, I would imagine he's got things floating around in his head because he's a super genius on, how he can potentially improve it. And that's a good way to be looking at things. I mean, always constant improvement, but I really think MagnaCut hits that balance. I mean, it's why we're using it. Mm-hmm. I mean, when I started doing this, and even today, if a steel came out that I thought was significantly better than MagnaCut, we would switch. Mm-hmm. I mean, we're not married to it, but I haven't seen anything yet. People have been really happy with it, and it's that balance between toughness. How hard can you get it and still have it be tough, and still be able to sharpen it, and still have corrosion resistance and all that stuff. So, so far, so good.
Yeah, good.
But
glad it's working out.
Well, man, I appreciate you coming out here, all the way from New York, and appreciate your support as we've grown. It's been awesome.
It has been. It's been fantastic. I mean, talking to you 4 years ago, I mean, I've talked to other guys that had big plans, and I was like, okay, well, we'll see how it goes. But you're one of the few that really followed through on it, and really great success story.
Well, I appreciate that.
Yeah.
No, I appreciate it, and we're proud to be able to work with you guys, and we've just done more and more on MagnaCut, and being able to make our steel here in America and support you guys and have you guys support us. It's pretty cool. So, and I know the customers like it. A lot of the videos that I posted, a lot of people commented on. I think they thought that was pretty cool. Seeing those guys actually working that steel.
Oh, good. Good.
So, yeah. Well, thanks. where can people find you? Or I guess, for the most part here, it would be knife makers if they were interested in having you make them steel or buying steel from you or cutting it or whatever. What's the best way to get a hold of you?
Just they can visit our website. It's nsm-ny.com. We have an online store. We also have a lot of distributors. I mean, we try to push individual makers to our distributors, and they're all listed on there. They have contacts.
And that's the best way, especially for people looking to do 6 or 8 or 10 knives here or there or whatever.
Yeah, you get a lot better price from buying from one of our distributors.
Right.
But if anybody needs something rolled down, I mean, like I say, we do a lot of conversion work, so they could always reach out to us and see if we can help them out. If
I send you a few bags of beer cans, like recycling, can you roll them nice and flat for us? We can get more in our can. You don't throw just aluminum cans in your Fords now and then, and
my God! So we used to do liquid nitrogen. So we were processing pure aluminum. For the semiconductor industry. So we had these tanks, and we would have a truck come in and pump liquid nitrogen into our coolers.
Yeah.
And all day long. So we're going through 50,000 cubic feet every 6 hours.
Holy shit.
So, you pull the aluminum out, you give it a pass, and it goes back into the tank. Well, one day I'm walking up to the mill with customers, and all of a sudden, boom, here's this loud explosion. They filled up a 2-liter bottle with liquid nitrogen, put the cap on, and just threw it out in the
in the shop floor.
Yeah, and it warmed up and just exploded.
Yeah, that's always fun. That was always fun. We did that in high school sometimes with like dry ice.
Right.
Throw a bottle out under somebody's cars or getting in it or whatever. Yeah, we had lots of fun.
Yeah,
doing stuff like stupid shit like that.
Yeah. But they're not allowed to throw things in the furnaces or in the rolls.
No, that's a bad deal. Yeah. All right. Well, thanks, Bob. I appreciate you coming by.
Yeah. Thanks, Josh.
All right.
Appreciate it.